The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Today, we're going to go on and take a look at section 7.6. I'd ask if there were any questions from yesterday, but since no one else is here, I won't bother. All righty, so here we go. Yesterday, we took a look at solving complex or simplifying complex fractions by multiplying the numerator and the denominator of a fraction by the least common denominator. Today, we're going to solve rational equations, that is, equations with rational expressions or fractions that are algebraic, by multiplying both sides of the equation by the same non-zero number. Recall from just basic solving algebraic equations, you can multiply or divide both sides of an equation by the same non-zero number. But that non-zero number we're going to choose is going to be the least common denominator of all the denominators in all the fractions in both sides of the equation. All right, so let's start out with something basic. We have the following. So again, this is from section 7.6. 2/3 equals 1/2 plus x over 6. Okay. Now, the denominators of this equation are 3, 2, and 6. The least common denominator of 2, 3, and 6 is 6. What we're going to do now is multiply both sides of the equation by 6. So on the left side of the equation, we get 6 times 2/3. On the right side of the equation, we get 6 times 1/2 plus 6 times x over 6. Okay, now we're going to go back through, and using that least common denominator as a multiplier, we can reduce out all of the denominators in all of the fractions. 6 over 3 reduces to 2 over 1, which leaves us with 2 times 2 over 1, which is 4, equals 6 over 2 reduces down to 3 over 1. So then we have 3 times 1 over 3, 3 times 1 over 1, which is 3, plus 6 times x over 6. The 6 is reduced to 1 over 1, and we have 1 times x. So now our new equation no longer has fractions. To solve this equation, we'll subtract 3 from both sides of the equation, and we get x equals 1. Let's go back and check our work by putting 1 in the place of x in the original equation. So we get 2/3 equals 1/2 plus 1/6. Again, this went right there. Okay. Well, let's see. We could again go back and multiply both sides by 6, and let's see what happens. 6 times 2/3 would be 12/3 or 4. 6 times 1/2 would be 6/2 or 3. 6 times 1/6 would be 6/6 or 1. 4 equals 4, so x equals 1 checks. All right, let's take a look at another example. We have, let's see here, 1/4 minus 5/6 equals 1 divided by a. So our least common denominator would be 12a, because 4 is 2 squared, 6 is 2 times 3, and a is just a. So we need 2 2s, a 3, and an a. So that's where we're getting 12a is our least common denominator. So now we're going to multiply both sides of the equation by 12a. We're going to distribute 12a times a quarter, 12a times minus 5/6, and on the right side, 12a times 1 over a. So I get 12a times a quarter minus 12a times 5/6 equals 12a times 1 over a. Going back and reducing and simplifying, 12 over 4 is 3 over 1. 3a times 1 all over 1 is 3a. Minus 12a times 5/6. 12 over 6 is 2 over 1. So I get minus 2a times 5, or 10a over 1, which is 10a, equals 12a times 1 over a. The a's reduced down, and we just get 12. Simplifying, combining like terms on the left side of the equation, 3a minus 10a is negative 7a. So negative 7a equals 12. Okay. And then dividing both sides by negative 7, a equals negative 12 over 7. Okay. Let's take a look at this equation. Let's see here. 10 divided by t minus t equals 3. Now, the least common denominator is just t, because recall that there's an implied 1 in those denominators. Okay. So the LCD is just t times 1 times 1, which is just t, right? Okay. So we're going to multiply both sides of the equation by t. I'm going to go ahead and erase that extra stuff because we don't really need it there. Okay. So distributing there and there, multiplying, we get t times 10 over t minus t times t equals t times 3. Reducing out the t's, we get 10 minus t squared equals 3t. So we've cleared the fractions, but this is a second degree equation. So let's put it in standard form. I'm going to move everything to the right side of the equation so that my leading term, which would be negative t squared, but moved to the other side, will be positive t squared. I want that to be positive, so I'm going to do this. I'm going to subtract 10 from both sides, and I'm going to add t squared to both sides. So now what I have is 0 equals t squared plus 3t minus 10. Okay. So now I have a second degree equation in standard form. Well, on the right side of the equation, we have a trinomial. Again, it's in standard form. There's no greatest common factor. It's not a perfect square, but the leading coefficient is a 1, so I can split it up this way. I'm looking for a product that's negative 10 and a sum that's 3. How about plus 5 and minus 2? Okay. So now take each factor that contains a variable, set it equal to 0, and solve that equation. So we're going to subtract 5 here and get t equals negative 5. We'll add 2 here and get t equals 2. So it appears that I have 2 solutions to this equation. Okay, just a minute here. Where did that go? Here we go. All right, so let's go back and let's check each of those solutions to see if they work. I'm going to do that on the next page. So I'm going to take this original equation and recopy it on the next page. Okay, so we've got 10 over t minus t equals 3. And our solutions were t equals -5 and t equals 2. So let's take the -5 and see what happens. 10 over -5 minus -5 equals 3. 10 over -5 is -2. Subtracting a negative is like adding a positive. We get 3 equals 3. It checks. So the solution is correct. All right. Let's take t equals 2 and try it. So we've got 10 over 2 minus 2 equals 3. 5 minus 2 equals 3. 3 equals 3. So that checks as well. So both solutions are correct. Right. Let's see what else we can do here. Let's see here. Let's do this equation. We have x plus 6 divided by x plus 4 plus 1 over x squared plus x minus 12 equals 1. All right. Now, to find the least common denominator, I need to factor each denominator. So let's see. I would have x plus 6 over x plus 4, because I can't do anything more there, plus 1 over x and x. And let's see, how about a plus 4 and a minus 3 equals 1. All right. Now, my least common denominator, I need an x plus 4 and an x minus 3. So I'm going to multiply both sides of the equation by the entire thing, x plus 4, x minus 3, and over here as well, x plus 4, x minus 3. I'm going to try and crowd this all in here. We'll see what happens. So I'm going to distribute this to here, and then to here, and then multiply that together. So starting on the left, I have the following. Let's see if I make this a little bigger. That might help. I've got x plus 4 times x minus 3 times x plus 6 over x plus 4. Okay? Plus x plus 4 times x minus 3 times 1 over x plus 4 times x minus 3 equals 1 times x plus 4 times x minus 3. So I took this times this times that, and that times that. Okay? Same thing we did on the previous problems, just more complicated looking stuff, but the same idea. So now I'm going to go back through and reduce and get rid of those denominators. The x plus 4 over x plus 4 reduces down to 1 over 1. So now I have what? X minus 3 times x plus 6. Let's go ahead and FOIL that together. We get x squared plus 6x minus 3x minus 18. Okay. And then here, that and that reduced down to 1 over 1. So we have plus 1 equals, and then over here, 1 times x plus 4 is x plus 4. And then we have what? X squared minus 3x plus 4x minus 12. So now I'm going to go back and combine like terms and simplify. So I get what? X squared plus 3x minus 17 equals x squared plus x minus 12. Okay. Well, it appears that I have a second degree equation. So I'm going to put everything on the left side of the equation set equal to 0. So I'm going to start out by subtracting x squared from both sides. However, when I do that, the x squareds cancel on both sides and I end up with the following equation. 3x minus 17 equals x minus 12. Well, this is no longer a second degree equation. Now it's a first degree equation. So to solve it, the strategy changes. I'll put x's on the left. 2x minus 17 equals negative 12. I'll put the constants on the right. And I'm running out of room. I've got 2x equals what? 5. I'm going to go up here. If I have 2x equals 5 and then I divide both sides by 5. Oops, wrong. Divide both sides by 2, I get x equals 5 halves. Okay. Sorry, I had to go all over the place to get that in there. All right, but again, we determined what the least common denominator was, multiplied every term in the equation by the least common denominator to clear out all the fractions, solve the equation. Okay, let's take a look at another example. Okay. 4 minus 8 over x plus 1 equals 8x over x plus 1. Okay, so each denominator is factored as much as it can be. The LCD is x plus 1 because recall there's just an implied 1 there, so that's not going to change the LCD from being x plus 1. All right, so now we're going to multiply both sides by x plus 1. So we're going to take x plus 1 times 4, and then x plus 1 times minus 8 over x plus 1, and then x plus 1 times 8x over x plus 1. Okay, so x plus 1 times 4 minus x plus 1 times 8 over x plus 1 equals x plus 1 times 8x over x plus 1. Simplifying, on the left side, we'll distribute 4x plus 4 minus the x plus 1's reduce out, so minus 8 equals, and over here the x plus 1's reduce out, equals 8x. Okay. So now, let's see here. Combining like terms, 4x minus 4 equals 8x. I'll solve for x on the left side of the equation. So I'll subtract 8x from both sides. Negative 4x minus 4 equals 0. I'll add 4 to both sides. Negative 4x equals 4. We'll divide both sides by negative 4 and x equals negative 1. Okay. Now, I checked my work on the very first problem I did way back, and then I just kind of ignored that process. But there's a danger in doing that. Here, the answer I got was x equals negative 1. And all the steps I went through seem to be correct. I don't think I made any mistakes. But let's check our work. Okay, let's take this original equation and let's put negative 1 in the place of x. What do we get? We get 4 minus 8 over negative 1 plus 1 equals 8 times -1 over -1 plus 1, which is 4 minus 8 over 0 equals -8 over 0. Oh, our solution doesn't work. Because dividing by 0 is undefined. So there is no solution. Okay. Now, if everything I did was legal, then how did I get a solution that didn't work? Well, actually, I did break the rules, but I didn't know it at the time. Consider this. I said this earlier. I said you can multiply or divide both sides of an equation by the same non-zero number. Well, if x is -1, what's this and this? -1 plus 1, that's 0. So unknowingly, I multiplied both sides of the equation by 0. So basically, that's why my solution didn't work. I broke the rules, but I didn't know it. Okay, now, this proposed solution that didn't work is called an extraneous solution. Okay, an extraneous solution is one that you get, but it doesn't work. In WebAssign, they will ask you to solve equations, and then they may ask you about, is a solution extraneous or not? And so if you get a solution using the correct process, but it doesn't work, then that would be an extraneous solution. So read that carefully in WebAssign. All right. Now, next of all, I want to take a look at solving formulas for a specified variable. Okay. Let's take this one, for instance. It says t equals 3r over capital M minus lowercase n. And we are to solve for r. Keep in mind, a lowercase letter and an uppercase letter are different. Now, I have different letters anyway, but if I could have a capital M and a small m in the same formula, and they are different variables, so don't get that confused. All right, to solve for r, what I'm going to do first of all is I'm going to clear the fraction. Okay, so I'm going to multiply both sides by m minus n, and over here, m minus n. So on the left side, I've got m minus n times t, and on the right side, I've got 3r. Now I'm going to come back and divide both sides by 3. So those will reduce out, and I'm going to have r equals m minus n times t all over 3. So we've solved for r. Okay. Let's see here. Let's take a look at this one. We have 2 divided by c plus 2 divided by d equals 1 divided by h. And we are to solve for c. Now, c in this formula is in the denominator. So getting rid of the 2 in the numerator of that term wouldn't solve it for c. That would be 1 over c. We need c to be by itself in the numerator. So what I'm going to do, I'm going to multiply both sides of this equation by the LCD, which is CDH. Okay, so CDH, CDH. Distributing here and multiplying there, I should get the following. I get CDH times 2 over C plus CDH times 2 over D equals CDH times 1 over H. Okay? Tell you what, let's move this over here so that you don't get confused. It doesn't really matter which side it's on because multiplication is commutative, but now going through and reducing, the C's go away, the D's go away, the H's go away. So I have 2DH plus 2CH equals CD. I'm trying to solve for C. I have 3 terms in my equation still. 2 of them contain the variable C, along with some other variables, and the other term does not contain the variable C. Let's get all the variables that contain C on one side of the equation. So I'm going to subtract 2CH from both sides, okay? So I get 2DH equals CD minus 2CH. So again, I've got all the terms with C on one side of the equation. So now comes the thing that students don't often think of. Here's the trick, if you will. I need to get C by itself. What I'm going to do is I'm going to factor C out of both terms on the right side of the equation. Okay, so take C out, common factor. Well, now I'm just one move away from the final answer. I'm going to divide both sides by D minus 2H. So now what do I have? I have 2DH over D minus 2H equals C. Now, the left side of this equation looks pretty complicated, but I have isolated C, which was the goal. All right. So you're going to want to put this idea of taking out the greatest common factor into your bag of tricks to have in the future. All right, let's see here. How about this one? F equals L squared divided by 6D plus D divided by 2. And we are to solve for L squared. So we're not going to solve for L, we're going to solve for L squared. All right, I've got a couple of options. One of them, I could multiply both sides by the least common denominator, which would be 6D. And then I could move the D over to the left. The other one would be to move the D over 2, subtract that from both sides, and then multiply both sides by 6D. Sometimes either method works. Sometimes one method you kind of go around in circles like a skunk chasing its tail, and you need to jump off the merry-go-round and try the other method. If there was anybody else here, I'd ask them which method they want, but I will just go ahead and I'm going to clear the fractions, okay? So the LCD would be 6D. So that times 6D, that times 6D, distributing and multiplying, I get 6D times F, okay, equals 6D times L squared over 6D plus 6D times D over 2. Okay, let's see here. Those are going to reduce out, and 6 over 2 is 3 over 1. So now I have 6DF equals L squared plus 3D squared. Okay. And let's see. Now I will subtract 3D squared from both sides, and I get 6DF minus 3D squared equals L squared. And there you go. I've solved for L squared. Okay. Let's see here. Let's take this problem. And we have 4 over y squared minus 4 equals 1 over y minus 2 plus 1 over y plus 2. Okay. So to solve this equation, I want to clear the fractions. If I factor this first denominator, it becomes y plus 2, y minus 2, right? So we could, let's cross that out and just go with a new denominator that's been factored. LCD is y plus 2, y minus 2. Okay. Now, let's see, on this side of the equation, I'm going to multiply by y plus 2, y minus 2. On this side of the equation, I'm going to multiply by y plus 2, y minus 2. I know I'm encroaching on the, well, let's see here. We'll move that over. LCD, y plus 2, y minus 2. Okay. So I'm going to multiply this together. I'm going to distribute this and this. On the left side, I have y plus 2 times y minus 2 times 4 over y plus 2 times y minus 2 equals, on the right side, y plus 2 times y minus 2 times 1 over y minus 2 plus y plus 2 times y minus 2 over y plus 2. And I switch the order and put the LCD in front of each case. Here, hang on. Let's do this so that it doesn't confuse people. And this is times 1 over y plus 2. There. It's the same thing ultimately, but all right. So now let's go back. On the left side of the equation, these reduce down to 1 over 1, so I'm left with 4 equals. On the right side of the equation, the y minus 2's reduce out, and I'm left with y plus 2 times 1, which is still just y plus 2. And then I have the y plus 2's reduced down to 1 over 1, and I have plus y minus 2 times 1, which is still that. So now what do I get? I get 4 equals 2y, combining like terms. Divide both sides by 2, y equals 2. So there is our proposed solution. However, notice if I take this and I go back up into my original equation, if I put a 2 there, that's fine. I get a 4 in the denominator. But if I put a 2 there or there, I get 0. Dividing by 0 is undefined, so this does not work. So there is no solution. And this one right here is an extraneous solution. Okay, it doesn't work. All right. Now, let's see here. I want to look at a couple of different scenarios. This author has what they call lookalikes, and I want to take a look at a lookalike. So this is part A. It says A over 3 plus 3/5 plus A over 15. That is an A, not a 9. Okay. Part B says A over 3 plus 3 over 5 equals A over 15. Now, here's where we need to be careful. Earlier on in this chapter, we were adding and subtracting monomials, or let's see what we're doing. Well, actually, it was even earlier on in the quarter. We were combining like terms, adding and subtracting fractions with different denominators and getting the same denominator and all that stuff, okay? Now we've been dealing with equations, and to solve the equation, to clear the fractions, we've been multiplying both sides of the equation by the LCD. We need to be careful though, because this is not an equation. So we cannot go in and multiply both sides by 15 because there aren't both sides. There's only one side, so to speak. It's not an equation. So all I can do is say, well, the LCD is 15, and then build everything up to where it has the LCD. Let's see. So here I'm going to go 5 over 5 and get 5a. Here I'm going to go 3 over 3 and get 9. And here it's already, that is a 9. It's already the has the least common denominator, so that's an a. So what do I have? I have 6a plus 9 over 15. Okay. I can factor a 3 out of the numerator and get 2a plus 3. I can factor a 3 out of the denominator. I can come back and reduce it down. And my final answer is 2a plus 3 over 5. So I didn't solve for a. I can't solve it. It's not an equation. I built each fraction to where it had the same denominator, added the fractions by adding their numerators over the common denominator, and then reduced it. Okay. Now, part B, this is an equation. I've still got that same LCD, which is 15, but here I can multiply both sides because we have both sides of an equal sign. Okay. So I've got 15 times a over 3 plus 15 times 3/5 equals 15 times a over 15. Distributing, multiplying. Let's see here, 15 over 3 is 5 over 1. So I have 5a. 15 over 5 is 3 over 1. So plus 9 equals 15 over 15 is 1 over 1. So that equals a. Okay, this is a 9. The others are a's. So I'm going to subtract a from both sides. I get 4a plus 9 equals 0. I'll subtract 9 from both sides and get 4a equals -9. I'll divide both sides by 4, and lo and behold, a equals -9/4. Let's try that again. A equals -9/4. So beware, if it's not an equation, you can't multiply both sides to clear the fractions because there aren't both sides. If it is an equation, you can do that, but always check your answer to make sure that it doesn't make the problem undefined. Let's go back for a minute and let's take a look at this one, okay? Now, if you're super confident in your math and you're like, oh, I don't want to bother checking my work, I know everything's right, you better at least do this. When you get an answer, plug it in any place in the denominator that it appears, because that's where the trouble is going to happen. For instance, in this problem, if y had been a 2 or a -2, neither one of those solutions would have worked. Okay. Okay, well, that's all I have for you today. It's been fun talking to myself. So I will be back this afternoon at 1:15. Have a great rest of the day. Bye now.